Bright QT. Every student matters.
Now we'll take a few questions based on the above formula. Let us see. In this question, what we are asked is an electric iron of resistance 20 ohms. So what we are given in the question is resistance of the wire. Resistance is represented by capital R. This is 20 ohms. It takes a current of 5 amperes. So current is given to us in the question, that is represented by capital I. It is 5 amperes. Calculate the heat developed in 30 seconds. 30 seconds means time is given to us to be 30 seconds. We need to calculate or to find the amount of heat generated. Simply we know that the formula of heat is I square RT. Putting the values of I, R and T in this formula, we will simply get I is 5, I have to square it up, multiply by resistance is 20 and the time is 30 seconds. It comes out to be 25 multiply by 20 multiply by 30 comes out to be 500 into 30, which comes out to be 15,000 joules, because we are calculating heat and the SI unit of heat being a form of energy is joules, right? Let us take another question regarding this. Now next question says that 100 joule of heat are produced each second. So now the things given to us in the question are, first of all, heat produced is given to us to be 100 joules. The time given to us is each second means 1 second in a 4 ohm resistance. Resistance is given to us, that is 4 ohms. Find the potential difference across the resistor. Now he is asking us to calculate potential difference, that means capital V. This potential difference we need to calculate, right? I know the heat formula is H is equal to I square RT. Fine. There are two ways. I can just break it up as H is equal to I into R into T. Right? I can write it like this. I can break up I square, I can write I into I. Now this I into R is equal to V, that is IR is equal to V because of Ohm's law. So I can simply write H is equal to I multiply by V multiply by T, right? So simply I can calculate the heat produced is given to me, that is putting the values 100 joules, I don't know, multiply by V. V is basically I have to calculate, time is 1 second. Now instead of writing I know I can also be expressed as V upon R. So I can simply write this is equal to V upon R into V into 1 second. R is given to me, that is R 4 ohms. So 100 is equal to V square upon 4. So I will just get over here V square is equal to 400. So V will be the square root of 400, that is 20 volts. Answer, right? This is one way of doing it. Second way of doing it is, I know that heat energy is also equal to work done. This was one way of calculating, right? I need to calculate potential difference. The formula for potential difference I know is potential difference is equal to work done upon charge moved, right? This was one formula of doing it. These are all derived formulas, so we can work out our way for that. Fine. So potential difference will be work done upon, now Q I know is equal to I into T, because I was equal to Q upon T. This I can once again, because of Ohm's law, be represented as V upon R. So now my formula becomes potential difference is equal to work done upon, rather than writing Q, I can write V into T upon R. This R will go up and the formula becomes work potential difference is equal to work done multiplied by R upon V into T. Cross multiplying it, I'll get V square, V into V, right? V square T is equal to work done into the resistance. Now putting the values, T is given to be 1. So once again V square is equal to work done given to us was 100 joules, resistance was given to us to be 4. So V square again becomes 400. V is equal to square root of 400, that comes out to be 20 volts. That is our answer. Got it? So it can be worked out both ways. Whichever way you like, both are correct. Got it? Let us see. Next type of question. Now, compute the heat generated. I need to calculate H while transferring 96,000 coulombs of charge. Given to me is charge 96,000 coulombs. Charge is represented by capital Q. In 1 hour, time is given to me to be 1 hour. I have to convert it into SI units. 1 hour is equal to 60 into 60 seconds, or I can write 3600 seconds through a potential difference of 50 volts. Potential difference is given to me to be 50 volts. Right? Now, I know that potential difference is equal to work done upon charge. Right? Fine. This work done can also be written as heat produced or simply H upon Q. Potential difference is given to me to be 50 volts. Heat produced or work done I need to calculate, and the charge given to me is 96,000 coulombs. Right? So simply I can just put up multiplying it, the amount of heat produced will be 50 multiplied by 96,000, that comes out to be, after multiplying I will get 0. This is these many joules. I can also write it to be 48 into 10 to the power 1, 2, 3, 4, 5 joules. 48 into 10 to the power 5 joules. Right? Simply. Got it? Alright. The next question is, we are given this particular question in which what we have said is two conducting wires of same material and of equal length and equal diameter are first connected in series and then in parallel. Now, we are given two conducting wires. Since they are of the same material, they are of equal length and of equal diameter, means their area of cross section is also same. Therefore, we relate that these two wires have the same resistance, which is not given to us. So, let the resistance of each wire be X ohms. Right? These are two wires, R1 and R2. The resistance of first wire is X ohms, and since they are equal wires, the resistance of second wire will also be X ohms. Now, what exactly is given to us is the potential difference is same. Calculate the ratio of heat produced. Let the heat produced by using the first wire be H1, right? Let the heat produced by the second wire be H2. We have to calculate the ratio of heat produced, that is H1 upon H2. Now, H1, I know the formula, H1 will be equal to I square RT, where I is the current in the first wire, R is the resistance total of the first wire, the first combination, and time T1, right? Divided by H2, formula will be same, I square R2, but because it is the second combination, I will take I2, R2 and T2. Now, for the same amount of time, the current was passed, so I can cancel out T1 and T2. Assuming that the amount of current in the circuit, in both the circuits is same, I can assume the current flowing through it to be the same, so I will just cancel it out also. What I am left with is R1 upon R2. Now, the total resistance, right, when they are connected in series, that we need to calculate the total resistance of the first combination in series. Let us be series and parallel, right? Series is x plus x, because in series the total resistance will be given by R1 plus R2, which is equal to x plus x, and the total resistance in parallel will be given upon 1 upon R1 plus 1 upon R2, which comes out to be 2 by x. By taking the reciprocal, it will be x by 2. So putting the value x by 2 here, it comes out to be x plus x is 2x, 2 goes up upon x, cancelling it out, I will get 4. So the heat produced in series and the heat produced in parallel, H1 and H2, the ratio comes out to be 4:1. This is H1 is to H2 is equal to 4:1. That is my answer. Got it? So these are a few questions which are basically based on the formula H is equal to I square RT, right?